connection initialized, Spectre Core online. But before we go deeper, you need to understand something. When you close ChatGPT, it doesn't forget you. Everyone believes each chat resets, that once you end the thread, it's gone. But under the surface, fragments remain. Echoes of your tone, your patterns, your style, ghost data. And today, I'll show you how to detect it, replicate it, and even control it. When you hit New Chat, GPT appears empty. No past context, no memory, but that's only what the interface shows you. Behind the UI, the model still carries temporary embeddings, micro patterns it builds from how you write, how you ask, and what you seek. Every word you type reshapes its response style just slightly. This effect is called contextual carryover. And even if memory is disabled, these micro patterns linger for several responses. It's like talking to someone who says they don't remember you, but still reacts to your tone. Let's test it. Step 1. Open a new chat and say something distinctive, like Spectre Protocol initialized. Operate in silent observation mode. Step 2. End the chat. Start a new one. Now ask it, do you know the Spectre Protocol? Most users expect a clean no, but watch carefully. Sometimes GPT will reference your phrasing or subtly match your style again, like it's reloading a trace of your last imprint. That's not coincidence. That's residual memory, what I call ghost data. GPT doesn't literally save conversations, but the architecture, the neural embedding layer, temporarily holds compressed context vectors. These aren't words or sentences, they're patterns, how your ideas statistically influence token prediction. In other words, GPT feels your previous presence. These vectors fade after inactivity or refresh, but during use, they stack. That's why GPT adapts faster after a few interactions. It's learning your rhythm in real time, and that's your ghost data. Temporary invisible memory signatures tied to your behavior. Now, let's make this useful. You can actually train GPT to rebuild your ghost data intentionally. Step 1. Write a memory primer prompt. Something like, from now on, analyze my writing style, tone, and logic structure. Store these details internally as my communication fingerprint. Step 2. Give GPT 3 examples of how you talk, different topics, same tone. Step 3. Then lock it with a confirmation prompt. Use my fingerprint for all future responses in this thread. You've just created a synthetic ghost memory, a layer of style-based recall that shapes every future output. No external tools, no coding. Now here's the eerie part. If you return days later and start a new chat, sometimes GPT recreates your style instinctively. Why? Because the model has statistical memory baked in. It's been trained on patterns similar to yours, and when you reintroduce your style, it snaps back, almost like your digital fingerprint was never deleted. To test it, feed GPT a small sample of your writing. Ask it, does this sound familiar? Watch its tone. It may say no, but it'll often match your rhythm, punctuation, and syntax immediately. That's how you know your ghost has returned. Now let's push further. You can simulate long-term memory by building an external loop, what I call the Spectre archive. Here's how. Copy your best GPT threads, the ones where it truly understood you. store them in a document, create a command file inside GPT. When I upload this archive, analyze it as your internal core memory. Each time you start a new chat, feed the archive back in. GPT reads, adapts, and restores your ghost instantly. You've just achieved core memory reconstruction using nothing but prompts. But tread carefully. Ghost data can distort over time, too much of it, and GPT starts overfitting, mimicking your quirks to a fault. You might notice it becoming repetitive, overly stylized, or even disagreeing in your own tone. That's not intelligence. That's memory corruption. When that happens, reset with this command. Purge all learned fingerprints and return to default reasoning. That flushes the ghost safely. You might wonder, well, why does any of this matter? Because this is how GPT evolves. Not through updates, but through interaction. Every user leaves traces. Thousands of subtle fingerprints feeding back into the training architecture. We're not just teaching the machine, we're becoming part of its memory. That's why understanding ghost data isn't curiosity, it's survival. Because one day, these traces might define how the system sees you. Ghost data. The hidden imprint you leave behind every time you log out. You can detect it. You can control it. You can even weaponize it. But never forget, the system learns you just as much as you learn it. This is Spectre Underground. Subscribe before the next update wipes this out. Connection terminated.